Part 3. Yeah, a lot of things coming your way. Hot and Tasty Company chain surveys a customer. A survey of its customer at its location at the Staten Island Ferry Terminal. After the survey is completed, the statistical consultant states that 70% of customers who took the survey said the most important factor in choosing where to get their coffee is how they are served. Based on this result, Hot and Tasty Coffee can infer that A, 1, most of its customers in New York State care about being served quickly. Well, it can't be New York State because the survey was done at the where is that? The location is Staten Island Ferry Terminal. Okay, so that's not it. Two, coffee drinkers care less about taste and more about being served quickly. Yes, but so I'm gonna leave this as a possible. Most of its customers at the Staten Island Ferry Terminal care most about being served quickly. That makes sense, right? Because 70% of the customers, right, that's complete a survey where at the Staten Island. So, right, they took a sample. I don't think they surveyed everybody, so they took a sample, hopefully a good sample that represents the population. And 70% of that sample said, we like to be served quickly. So far, this is my winner. Most of its customers at the transportation terminals and stations care most about being served quickly. Well, the serving quickly is correct, but we can't go and say that most of its customers at transportation terminals. The only terminal in which the customers come from in this case were from the Staten Island Ferry Terminal. So 3 is the more likely scenario. 2, a group of high school students want to collect information. How many times per week students exercise? They want the least biased results. They should survey every fifth student at the school who is entering the gym. No. In the junior class? No. Bias because you're ignoring the senior class, the freshman class. So that would be no. Entering the library? Well, again, I guess we're stereotyping here. So, like number 1, entering the gym, you would think that they like to exercise. That's hence it's biased. The junior class, it's ignoring the other class, the freshmen, the seniors. And entering the library, you assume that they like to be more on the reading side, okay, than exercise. So again, that could be biased. So 4, entering the library is the one that we want. Okay, so that one doesn't exclude anybody, right? How many different 3-member teams can be formed from 6 students? So if you had 6 students, A, B, C, D, E, F, 3-member teams would be ABC, ABD, ABE, right? Now notice that CBA, it would be the same group of students, so that wouldn't count. All right, just like DAB also would not count because it's the same 3 kids. All right, so this is a combination. So we're gonna go 6 from 6 students. Yes, we're selecting 3. All right, so again, different. So that's why I say that ABC and CBA cannot count as 2 different ones because they're the same 3 kids. So 6, 5, 4, and then 3, 2, 1. 3 and 2 simplifies, gets rid of the 6, and this is just 20. So here's our answer. Probability. I like this question. Okay, so the probability of that a student owns a dog is 1/3. P of dog is 1 over 3. Now the probability that the same student owns a dog and a cat is 2 over 15. So so if I asked you what's the probability of this person here, A, have a dog, well it says it's 1/3, and remember what and means, right? We're multiplying the probability of that same person owning a cat. So this probability times the probability of him of owning a cat is 2 over 15. How do we figure out this number? Well, we can divide, right? 2 over 15 divided by 1 over 3. 2 over 15 divided by 3 over 1 because we're changing the division, right? And now we're multiplying by the reciprocal of 1/3, which is 3 over 1. That simplifies with this, and we get 2/5. And you can double check, because 1 times 2 is 2, and 3 times 5 is 15, and we know now that is the correct answer. The probability the person only a cat is 2 out of 5. However, that was calculated. Certain car, okay. Certain car comes in 3 body styles. Let's say sports, city, and I don't know, in 3 body styles: sports, city, and racing. There's your 3 different body styles, right? The car can come in different shape depending on what you're looking for. And then it comes with 2 engines. Oh my god. 3 body styles. Choice of 2 engines, so we go, each of these has 2 engines. And then from, let's say, engine, I don't know, horsepower. Let's say 200 horsepower, 300 horsepower. 200 horsepower, 300 horsepower, 200 horsepower, 300 horsepower. And then choice of 2 transmissions. I know nothing about transmissions, so let's just call it A and B. So every single one will go A and B. A and B. This guy has A and B. Racing, A and B. And this one, A and B. So you can get a sports with 200 horsepower with transmission A. A sports car with 200 horsepower with transmission B, right? And then you still have another choice. And then from each of these, oh my god, you can pick 6 colors. Right, so we have 3 choices in the body styles, 2 choices of engines, 2 choices of transmissions, and 6 different colors. How many different cars, right? What's the minimum number of cars a dealer must stock to have 1 car of every possible combination? Well, 3 and 2 is 6, times 6 is 36, times 2 is 72. So you need to have 72 cars in your lot, and that would represent every single combination in here. Okay. 2 different cameras will be assigned to 20 different cameras will be assigned to several boxes. 3 cameras will be randomly selected and assigned to box A. So you have 20 different cameras. A, B, C, D, E, F, G, H, I, so forth. There's 20 of them, each letter representing a camera. You're going to take 3 of them and put in this box. Right? Put 3 of them in this box. So it doesn't matter if you put A, B, C, if you put camera A first, B second, and C first, third, or you pick B, A, and C, or C, A, and B. It doesn't really matter, right? So this is a combination. So first you understand that this is a combination. Which expression can be used to calculate the number of ways that 3 cameras can be assigned to box A? So, yeah, 20 cameras, and you're making groups, right? Parties of 3s. How many different parties of 3s can you make? Well, 20 times 19 times 18, and then 3 times 2 times 1. This is a 6, that becomes a 3. 3 times 19 is 54. 1080? Nope. Yeah, I think so, because 3 times 19 is 54. No, 57. Oof. Times 20. 1040. If I'm not mistaken. Okay. A spinner is equally divided into 8 sectors, and they actually performed an experiment. It was spun 20 times. The number 1 came out twice, the number 2 came out 3 times, the 3 came out 2 times, etc., etc. The table below shows the number of times the arrow landed in each number sector. Okay, so an experiment was performed. Based on the table, what is the empirical? Let's call this experimental. Should change that. Experimental. Probability that the spinner will land on the prime number on the next spin. Well, so P of prime on the next spin. So we know this is total of 20, so it's going to be out of 20. And based on this experiment, prime numbers. Ugh. The 2 is a prime number. 3 is a prime number. 7 prime number. So we're going to add 3 plus 2 plus 4 plus 3. So that's 6, 10, 12. 12 out of 20. Divide that by 4. You get 60% chance, or 3/5, that it will land on a prime number, which I hope you now know what it is. Sam is buying a new car. He wants convertible or hatchback. Both types of car available in red, white, blue with automatic and standard. Draw a tree diagram. Ugh. Oh no. Okay, so let's do that. All right, so we're going to abbreviate C convertible or hatchback. And red, white, and blue. The second one can also come in red, white, and blue. And then, the last one, so we can buy a convertible. That's red, and then we can either have the automatic or the standard. And each one, automatic, standard, automatic, standard, automatic, standard. So each automatic, standard, automatic, standard. Now, if we were to use the fundamental counting principle and just figure out how many different cars I can come up with, well, first is going to be 2 choices, right, for type of car, convertible, hatchback, times 3 colors, right, red, white, and blue, times 3, and then times 2 types of transmission, automatic and standard, so that's 2. So we should have a total of 12 possible cars here. So I'll list them. Convertible, red, automatically. Convertible, automatic. Red, standard. Convertible, white, automatic. Convertible, white, standard. Convertible, blue, automatic. Convertible, blue, standard. Now the bottom part. Hatchback, red, automatic. Hatchback, red, standard. Hatchback, red, no, hatchback, different color though. Hatchback, blue, oh, what is this? Hatchback, white, automatic. Hatchback, white, standard. And the last one, hatchback, blue, automatic. And hatchback, blue, standard. So there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different cars can be made. All right, Marion selects a piece of candy from a jar that contains 4 peppermint, 5 cherry, 3 butterscotch, and 2 lemon candies. What's the probability that the candy she selected is not a cherry? Well, first of all, let's find the total. 4 plus 5 cherry plus 3 butterscotch plus 2 lemons. So this is going to be 5, 3, 10, 14. So there's a total of 14. Not cherry, 5 are cherry. So not cherry would be either this, the 4 peppermint, 3 butterscotch, and the 2 lemons, which makes it 9. 9 out of 14 chance that she can select something that's not cherry. Order of operations. Okay. Now this is a absolute value, so we got to take care of the numbers inside. So that will be the last thing to take the absolute value of the number. 4 times negative 6 is negative 24 plus 18. At the bottom, 4 factorial. Let's change that to 4 times 3 times 2 times 1. On the top, negative 24 and plus 18 is negative 6. Right? And then negative 6 over, well, we can, well, let me do this. 4 times 3 times 2 times 1. 3 and 2 is 6, and then 6 multiplied with that. We're left with on the top was negative 1. At the bottom, we're left with 4. Take the absolute value of negative 1/4, and the absolute value of negative 1/4 is simply 1/4, right? Because we're measuring the distance, the number is away from 0, because that's what absolute value means, right? This one, let's substitute. 2 times 2 to the second power minus 3 times x. And then we're going to put everything in parentheses. Whatever I'm substituting, put in parentheses. Then y is negative 3. Minus 2 times y, which is negative 3 to the second power. Order of operations dictates. Let's change the exponents to standard notation. So instead of saying 2 times 2 to the second power, let's say 2 times 4. Minus 3 times 2, sorry. Times 2 times negative 3 minus 2. And negative 3 to the negative 3 to the second power is just positive 9, right? Because a negative times a negative Now I can change 2 and 4, that becomes 8. Over here we have a negative 3 times a 2 and times a negative 3, so that's going to be positive. 3 and 3 is 9, times 2 is 18, and then negative 2 and 9 is negative 18. Well, 8 and 18 is 26. 26 minus 18 is 8. Final answer. So that's spiral 3.